al canal. Hoy queremos realizar con vosotros un viaje hasta un lugar muy especial. Titán, la luna más grande de Saturno y la segunda del sistema solar tras la luna de Júpiter Ganimedes. De hecho, Titán es un objeto más grande que Mercurio. Es un lugar extraordinario porque además es el único lugar del sistema solar, aparte de la Tierra, que alberga ríos y lagos en su superficie. No solo eso, también presenta tiempo, clima. Encontramos lluvia, encontramos viento, encontramos dunas e incluso olas. Un lugar fascinante que atrae a los científicos y que nos invita a explorar. La sonda Cassini-Huygens es un proyecto conjunto de la NASA y la Agencia Espacial Europea, en el cual está compuesto por dos partes. La sonda Cassini, un orbitador que recoge información de Saturno y de todo su sistema de lunas, y la sonda Huygens, la parte que aportó la ESA. Un objeto que fue enviado a la superficie de Titán. Es, de hecho, el objeto humano que más lejos ha tomado Tierra. Las imágenes de su aterrizaje, de las que disfrutaremos en este pequeño documental, son impresionantes. Pero no veremos solo eso. También sobrevolaremos parte de la superficie de Titán, en concreto su hemisferio norte, donde se acumulan la mayor parte de las masas líquidas de este planeta Luna. Esas masas líquidas son sorprendentes. Titán es un mundo helado, con temperaturas cercanas a los 290 grados centígrados bajo cero, donde por lo tanto el agua líquida es imposible. Los lagos y ríos de Titán están hechos de metano y etano, lo cual conforma la posibilidad de nuevos tipos de vida. Un asunto que también tocaremos en este vídeo. También encontraréis un resumen detallado de la misión espacial Cassini-Huygens. Espero que disfrutéis de este vídeo tanto como yo lo he hecho. Un saludo.
One of the most shocking discoveries of the past 10 years is how much the landscape of Saturn's moon Titan resembles Earth. Like our own blue planet, the surface of Titan is dotted with lakes and seas. It has river channels, islands, mud, rain clouds, and maybe even rainbows. The giant moon is undeniably wet. The water on Titan is not, however, H2O. With a surface temperature dipping 290 degrees Fahrenheit below zero, Titan is far too cold for liquid water. Instead, researchers believe the fluid that sculpts Titan is an unknown mixture of methane, ethane, and other hard-to-freeze hydrocarbons. The idea that Titan is a wet world with its own alien waters is widely accepted by planetary scientists. Nothing else can account for the opposite, where most of the lakes are located, has been locked in a grip of winter. Cold, heavy air barely stirs and seldom reaches the threshold for wave making. But now the seasons are changing. In August 2009, the sun crossed Titan's equator heading north. Summer is coming, bringing light, heat, and wind to Titan's lake country. According to climate models, winds will pick up as we approach the solstice in 2017 and should be strong enough for waves, he says. If waves appear, Cassini should be able to detect them. Radar reflections from wavy lake surfaces can tell researchers a great deal. Wave dimensions, for instance, may reveal the viscosity of the underlying fluid and thus its chemical composition. Hayes is excited about bringing oceanography to another world.
I'm Connor Nixon. I'm a planetary scientist at NASA's Goddard Space Flight Center, and I study the atmospheric composition of the outer planets. Titan is Saturn's largest moon. It's actually the second largest moon in the solar system, and it's the only moon in the solar system that has a large and substantial atmosphere. And that atmosphere in some respects is really similar to that of the Earth, being composed mainly of nitrogen, but in other respects it's really different. It has methane as its second most abundant gas, and that takes the same role as water vapor in the Earth's atmosphere. It evaporates from the surface, it forms clouds, and then rains down again, and in fact forms lakes that we see at Titan's North Pole, including ethane and propane and all sorts of complex chemicals. We also see these vast dune fields at the equator, which are not made of silicates as they are on the Earth, but actually made of organic substances, essentially plastics, which have actually sedimented from the atmosphere and are being blown around into dune fields, the same as we'd see on a desert on the Earth. Back in 1980, when Voyager 1 flew by Titan and made the first close encounter with that moon, it discovered many new chemical species in the atmosphere. And a lot of these are what we call hydrocarbons, which are composed of two types of atom, carbon and hydrogen. And these are derived from methane. After the methane is broken apart by sunlight, it forms into longer and longer chain molecules. So you can add first two carbons together, to make a family of molecules, and you can also form 3 carbons together to form a heavier family of molecules. So it was actually very mysterious that Voyager only discovered the heaviest and lightest members of the 3-carbon family, but it didn't find the middle member of the family, propylene, that was missing. So NASA has this wonderful flagship spacecraft called Cassini, which is currently orbiting Saturn and is making multiple close flybys of Titan. Now in visible light, Titan appears quite bland and featureless, just like an orange globe, but Cassini has techniques to peer through that haze, including the composite infrared spectrometer, or CIRS, which can look at the heat coming from the atmosphere and split it apart into its different frequencies, and this forms a characteristic pattern of peaks which give the characteristic signatures of different molecules. And through this we can detect which molecules are in the atmosphere. We see all the molecules that were previously discovered by Voyager. But we're also able to look for new molecules, and in fact, buried within the signatures of these more abundant molecular species, we saw a very small spike, which was due to a new species which had not been seen before. And in fact, this was propylene. We saw it at multiple altitudes in Titan's atmosphere. When we added all the signal together, we had more than 99% confidence that we were discovering a new molecule. So this object I have right here, this is polypropylene. This is a plastic we use on the Earth in everyday household objects, such as this plastic tub here. And if we turn it over on the bottom, we find a symbol, the number 5, that says PP, polypropylene. This is the propylene that we found on Titan, but polymerized. That means that the molecule is formed into long chains, and when these chains are tangled together, it forms a hard, clear plastic that we use in many household objects. So that was really fun for me to realize that something that we discovered in space was in fact something that I was touching every day on the Earth. So the discovery of propylene on Titan is really exciting. First of all, it completes this chemical family where we had this missing link dating 32 years back to Voyager. But also it shows that there's much more there still in Titan's atmosphere to be discovered. Some people think that Titan is similar to the prebiotic Earth long ago, when the molecules were forming the basis of life. And we don't know what we're going to find on Titan if we send back further spacecraft with new instruments, more sensitive instruments, if some of the molecules on Titan could be similar to the basis of life on Earth.
Where else might life exist in our solar system? That's a question that NASA scientists are trying to answer. An intriguing place we are studying is Saturn's largest moon, Titan. It's the only body in the solar system, other than Earth, to feature seas of liquid on its surface. But that liquid is methane instead of water. The cell membranes we have on Earth, part of our building blocks for life, could not form here. Previous computer simulations investigated which chemicals could be used to make cell-like membranes on Titan. It's been calculated that this molecule, acrylonitrile, is the best candidate to form the most stable membranes. What's exciting is that our team at NASA Goddard has now detected large amounts of this chemical in Titan's atmosphere using spectroscopic data from ALMA, the Atacama Large Millimeter Submillimeter Array, located in Chile. And since Titan has rain, a significant amount may be reaching the surface and ending up in Titan's vast lakes. More research is needed, but by definitively detecting this astrobiologically relevant molecule on Titan, we are another step closer to understanding how and where life could exist in our solar system.
from Voyager, Titan was so unusual. All we could see from Voyager is this hazy world we couldn't see through to the surface. And that's why we had to go back with Cassini, carrying the Huygens probe, to try and see what does the surface of Titan look like. So the Huygens probe parachuted through in 2005, and we landed on the surface, and we saw an amazing world. It was incredible how Earth-like Titan appeared. It had river channels, it had lakes, it had sand dunes. The only difference is it's very cold on Titan, and the liquid that flows through Titan's rivers is methane instead of water.
The Cassini-Huygens mission has been one of the greatest voyages of discovery in the history of science. We have learned and discovered more things about a previously unknown dynamic system, a system that's 1 billion miles from us, the Saturn system, than we ever could have imagined. One of the pinnacles of that has been the discoveries on Titan. Titan has turned out to be a very complex world. It has geology, it has methane rain, it has lakes and seas, it has dunes of organic molecules, and it has a lot more secrets that it's still hiding from us.
I think that really makes people so excited about Titan is this combination of familiarity and alienness. We've had 126 close flybys with a spacecraft with a dozen instruments that in each of those flybys are all taking data about different aspects of Titan.
Not only was Titan fascinating in its own right, a moon the size of the planet Mercury, it was also Cassini's gas tank. It allowed us to change the shape and orientation of the orbit to explore the poles of Saturn and the rings and all of the icy moons by carrying a lot less fuel than we would have to have carried otherwise. It gave us the energy to go all the way across the rings and fly between the gap between the rings and the planet.
Because of these flybys of Titan, using Titan as a gravitational slingshot, and so many of the other remarkable discoveries that have been made by Cassini, for example, mapping the composition of the plume of Enceladus, would not have been possible without Titan there. We could not have gotten to these places without using Titan.
And so I think Titan has really been a particularly special place to explore just because of all of the complexity in the system and the puzzles that it has given us.